today we are going to solve this very easy problem from IIT JAM-MS 2023. So we are given a random variable x which have a probability mass function px, and we are given the recursion relation px plus 1 equal to ln 3 by x plus 1 into px, where the range of x is from 0 to infinity. We need to find the variance of x. To find the variance of x, we basically need to know the distribution that x follows. So we will identify the distribution of x from this given recursion relation. So let us proceed to the solution part. Let us consider a random variable x which follows Poisson lambda. Then the PMF of x can be written as px equals to x e to the power minus lambda to the power x by x factorial, where the range of x is from 0 to infinity. Now p probability x equals to x plus 1 turns out to be lambda by x plus 1 into e to the power minus lambda to the power x by x factorial, which can be written as lambda by x plus 1 into probability x equal to x. Now if we put lambda equal to ln 3, we get probability x plus 1 equal to ln 3 by x plus 1 into px, which matches with our recursion relation given in our question. Hence we can say that the random variable x follows Poisson ln 3. So the variance of x will be ln 3. Hence option A is true in this case. It was a very easy problem. So in this case option A turns out to be true, that is ln 3.
Hello guys, welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM-MS, ISI MStat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses. To book a trial class for your preparation courses of IIT JAM-MS, ISI MStat, and CMI MSc Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
Today we are going to solve problem 32 of IIT JAM-MS 2023. It is an MSQ type question, so multiple select answers could be correct from among the four options. So we are given let x1, x2, x3 be ideal random variables, each having standard normal distribution. Then which of the following statements are true? So we will check each of the following statements one by one. Let us proceed to the solution part. So we are given x1, x2, x3 following standard normal distribution. So x1 minus x2 and x1 plus x2 being linear combinations of normal distribution will follow. Normal distribution will parameter 0, 2. So standardizing the both of them, we get each of them follow normal 0, 1 distribution. So x1 plus x2 whole square by 2 will follow chi-square distribution, and x1 minus x2 whole square by 2 will follow chi-square distribution. This part is completely trivial. Now, what is our option A? Option A tells us that this expression follows t distribution with 1 degrees of freedom. So let us check it. So root 2 x1 minus x2 by root over of x1 plus x2 plus 2 x3 square. This thing can be written as x1 minus x2 by root over of x1 plus x2 whole square by 2 plus x3 square, just bringing these two in the denominator. Again, dividing the numerator and denominator by root 2, we get x1 minus x2 by root 2 and root over of x1 plus x2 whole square by 2 plus x3 square by root 2. Now note that this one follows normal distribution, this part from here, and this part is nothing but chi-square, and this is chi-square 1 distribution and this is chi-square 1 distribution. So adding them follow chi-square 2 distribution divided by 2, which is the degrees of freedom. So normal, and it is a ratio of standard normal distribution by root over of chi-square 2 by 2, which is nothing but t distribution with 2 degrees of freedom. So option A is false, because in the option A it is said that it should follow t distribution with 1 degrees of freedom. So option A is false. Now option B tells us that this expression We'll follow F distribution with 1 and 2 degrees of freedom. Let us check it. So x1 plus x2 whole square by x1 minus x2 whole square plus 2x3 square. Again dividing it by 2, we get x1 plus x2 whole square by 2 by x1 minus x2 whole square by 2 plus x3 square. Again, this is nothing but chi square 1 distribution, and this is chi square 2 distribution. These are the ratios of two chi square distribution, which follows beta distribution with the parameters half, comma 1. This is a well established fact. So option B is again false. Now option C tells us that this expectation should be 0. So let us check it. Expectation of x1 by x2 square plus x3 square. Now this expectation can be written in the product form as expectation of x1 into expectation of 1 by x2 square plus x3 square. The reason that we can able to write them as product is because x1, x2, x3 are independent, and since x2 square and plus x3 square is a function of x2 square, x2 and x3, which is independent of x1. So and this expectation is obviously 0 as x1 follows normal 0-1 distribution. So option C turns out to be 2. Now at last we need to check the last option, which tells us that this probability x1 less than x2 plus x3 is equal to 1 by 3. So let us check it. So we are defining a new random variable y, which is equal to x1 minus x2 plus x3, which again follows normal distribution with parameters 0, 3. So our required probability is nothing but probability y less than 0. Standardizing it, we get it as capital phi of 0, which is half. So option D turns out to be false because in the option it is said it should be 1 by 3, which is not. Here it is, we are getting it to be half. So the only correct option is C. So in this case, our only correct option is C.